What is simple interest and how is it calculated? By the time you finish watching this video, you should be able to answer those two questions. So first of all, let's talk about interest in general. Can you think of a financial example of a situation where you either earned money, earned interest, or you were charged interest? Two common examples would be bank accounts. That's an example where you're hopefully earning interest. And a credit card is a situation in which you would be paying interest. Another one is a student loan. You would have to pay interest if you have one of those. Now we have two types of interest, simple and compound, and we'll talk about simple interest in this video, and we'll talk about compound interest in the future. Simple interest is just a one-time percent of an amount of money. Now you won't see simple interest for things like bank accounts or credit cards, but you will see simple interest for any sort of a purchase that you make and can't pay right away, and there's some sort of a financing fee for the privilege of paying for that in installments. Some people purchase things like computers or washers and dryers using financing, and you're able to take that item home right away and pay some interest for being able to pay for that in installments. Compound interest, you're earning a percentage of an original amount as well as a percentage of the new amount, including the previously calculated interest. So compound interest is actually interest not only on whatever you, let's say it's a bank account, it's not only on whatever you deposited, but you're also earning interest on the interest. And you've probably seen how this works against you in a situation like a student loan, right? The interest compounds, or maybe even a credit card, and the longer you wait to pay that off, the higher the interest gets because you're being charged not just on whatever you charged and put on the card, but also on the interest that keeps accumulating. Now there are some terms that we need to know to be able to calculate and work with simple interest. First off, we have interest, which is the fee charged for the use of money, and we use a capital I to represent interest. Principal, represented by a capital P, is the amount of money that's borrowed or placed into a savings account. This is called principal because it's the first or the starting amount. It's kind of like the initial amount. And then rate, represented by a lowercase r, is the percent of the principal that's paid for having money loaned or earned for investing the money. And in this textbook, unless you see it indicated otherwise, we're going to assume that all the rates are given as percents per year. So if you see something like 7%, then that's an annual rate, or 7% per year. Time, or the term, represented by lowercase t, is the length of time that the money is being borrowed or invested. So you may see an annuity, a 10-year annuity, and we have some money being invested for a total of 10 years. Then the future value, represented by A, is the amount of the loan or the investment plus the interest paid or earned. So if this is a bank account and you want to know what's the future value of the account in 10 years, there should be whatever you put in there, that's like your investment, plus whatever interest you earned during that time. We also have a formula for calculating simple interest. Interest equals principal times rate times time, or in variables I equals PRT. So to see how this works, let's look at a simple example. Let's say that you deposit $100 in a banking account, and let's say that you earn interest using simple interest. In real life, it's actually compound interest in most cases, but for the sake of this example, we'll pretend that it's simple. Okay, so $100 in the bank account, and let's say you make 2% annually on that money. Okay, also a bit unrealistic. The rates are not that good right now. So here's how the interest would be calculated. All right, each year you're earning 2%, which means we take 2% of $100, and that's the amount of interest that you would earn. Okay, so in the previous section, section 1, you learned that to take a percentage of something, you multiply by that percentage as a decimal. Okay, so 2% as a decimal is 0.02, and 2% of 100 is $2. Okay, so at the end of that first year, you would have earned $2 in interest. Okay. Now let's say that you left the money in there for 5 years. Okay, well, how much would you expect to earn? Well, you would earn 5 times that amount. Okay, so $2 each year for 5 years, and you would earn a total of $10 in interest. Okay. And there you can see we've used this formula. This is principal times rate times time. Okay, so that's simple interest. Now we also have a formula for future value, and this is just principal plus interest. So whatever is, let's talk about a loan on this one. Okay, the future value would be the amount that you owe back. So let's say that this is a 4-year student loan. Then the amount that you would owe back is whatever you borrowed plus whatever interest has accumulated during that time period. Okay. Now in variables, that's A equals P plus I. And we also have this second formula, A equals P times the sum of 1 plus RT. Okay. Now this actually isn't a new formula, it's just written a little bit differently. So let's see where this one comes from. If we start out with A equals P plus I, the first formula, okay, and then we notice that instead of writing I for interest, we know that I is found by doing principal times rate times time. Then I can substitute that in. And then this is an algebraic step called factoring out a variable. You may remember this. If not, basically what we're doing is dividing each of these things in the sum by whatever they have in common. So notice that there's a principal in each of these. These are called terms, okay, the things on either side of the plus sign. And so if we divide by the principal and we look at what's left, well, principal divided by principal is 1. Okay, picture like 100 divided by 100, that would be 1. And then principal times rate times time, well, if we divide that by principal, then all that's left is rate times time. Okay, so there we have it. This is the second formula. All right, and well, why do we need this? What's wrong with the first one? It depends on the situation. Sometimes if you've already calculated the interest, then it's easy to just do one more addition to find the future value by adding principal and interest. However, if you're mostly interested in future value and you haven't calculated the interest yet, then the second formula allows you to do that all in one step. Alright, so let's try it out. Let's do an example and calculate simple interest and future value. So first, let's find the simple interest on a loan of $3,600 for 3 years at a rate of 8% per year. Okay, so we'll solve for different things in some of these examples. So first of all, let's focus on what we're supposed to find. Okay, find the simple interest. And that also gives us a clue as to which equation to use. So right now we've only talked about simple interest, but as you go throughout this chapter and develop more formulas, you'll need to know which one to use. So this is the clue that lets us know we should use the formula or the equation I equals PRT. Okay. Now I'm solving for interest for I don't know that, but I do know all of these other values, so I'll substitute those in now. Okay, the principal is the starting amount, and this is a loan, so it's the amount that's borrowed, and that's $3,600. Okay, then the rate is 8%, and in these problems we always want to use the rate as a decimal. So instead of 8%, I'll write 0.08. Okay, and then the time, 3 years. Alright, so then we need to make that calculation, and you'd pull out your calculator at this point. Okay, and that's $864 in interest. Now, example 2, find the future value for the loan in example 1. Okay, so future value would be the total amount that needs to be paid back, or in other words, the principal, the amount that was borrowed, plus all of that interest that's accumulated. So that would be $3,600 plus the $864 in interest. All right, and then this person owes back a total of $4,464. Now here's a note: when using this formula, we need to make sure that the rate and the time are consistent, that they agree in units. So if we have the rate as a percent per year, then we need to express the time in years as well. Okay, so 5% per year. Okay, then we need time in years. If the rate is a percent per month, express the time in months. Okay, and so forth. If it's a daily rate, express the time in days. So what we need to do sometimes is make some conversions. We can convert either the time or the percent so that they both match. And typically I'll always convert the time, but if you want to convert the percentage, that would work just as well. Okay, so let's try one of these out. To make payroll during a down period, United Ceramics Incorporated needed to borrow $2,000 at 4% simple interest for 3 months. Find the interest. Okay, so again, let's focus on what we need to find: interest. And if we look for a clue in this problem, we are told that this is simple interest. So again, we're using I equals PRT. And then let's start filling in what we know. Okay, we don't know interest, that's what we're solving for. Principal is the amount that was borrowed, so $2,000. Okay, rate is 4%. And remember, if it doesn't specify the time period for a rate, we're going to assume that it's annually. So 4% is 4% annually. Okay, well now when we get to time, time is in months. So I can't use it in months, I need to convert to years. Alright, so off to the side here, what I need to know is 3 months is how many years. Now the easiest way to do this is just to divide by the number of months in a year. Divide by 12 months. Okay, so I'm making a fraction. The part of the year that I have, 3 months, divided by the total number of months in a year, and that gives me a fraction that represents the number of years. So that's 3/12, and I can reduce that to 1/4. Okay, so 3 months is a quarter of a year, or you might also choose to write that as a decimal, 0.25. Alright, so that's what I want to use for time. Okay, and then go ahead and make that calculation, and that's $20 in interest. Okay. Now let's do one more example of converting a time period like this. Actually, let's do 2 more. Okay, so this is unrelated to example 3, but let's say we had a time period of, I don't know, let's say 5 months. Okay, how many years is that? Well, same thing, we would just divide by 12 months. Alright, and this one doesn't convert nicely to an exact decimal, and I want to stay as accurate as possible without rounding. So I would just leave this as 5/12 when we enter that in for the time. Alright, and then what about something like maybe 31 months? Okay, well, same thing. This is more than a year. It's more than 12 months, but I can still divide by 12 months, and that would tell me how many years I have. Alright, so again, this is 2.58333 repeating, so I would just leave this as 31/12 when I go to enter that for the years. Okay. On the other hand, if we had something like 30 months, okay, I would still divide by 12 to see how many years that is. Alright, and then that one can be written as a decimal if you like, and that's 2.5 years. Okay, or you could leave it as 30 over 12 if you wanted to. All right, so there are 3 examples. So converting from months to years, just divide by 12 to get the number of years. Okay, and how would we go backwards from years to months? Well, same idea. You would take the years and multiply by 12 months. Okay, so instead of dividing, you'd multiply. All right, we'll do one more example with calculating interest, future value, and then also something we haven't done yet, monthly payments. All right, we have a chauffeur service that borrowed $600 at 9% simple interest for 1.5 years. Find the interest, future value, and the monthly payment. Okay, so interest is going to be the same formula, I equals PRT. So we have $600, then the rate is 9%. That's an annual rate. And so we need time in years, which we have, 1.5 years. All right. And multiplying, that's $81 in interest. Okay. Now future value, that's principal plus interest. All right, so the amount they borrowed, that's $600 plus the $81 in interest. And at the end of those 1.5 years, they owe $681. Okay. Now the last thing to do is to calculate the monthly payments. So basically what's done is at the beginning of the time period, the bank or whoever's lending this money would sit down and make these 2 calculations, and they would see what this chauffeur service owes at the end of those 1.5 years. Okay, so they would find that that's $681, and then they would just split that up into the number of months in 1.5 years and make sure that this company's paying back that loan over those, those 1.5 years, so that by the time the time is up, they've paid back everything that they owed. So if we needed a formula for this, we could make one. Okay. Now I'll use the capital R. Your book uses that later on for a regular monthly payment. Okay, or you can use an M if you like for monthly payment. And to find the monthly payment, you take the future value, the total amount that's owed, and you divide that by the number of months in the time period. So we're going to divide by T, but we need to make sure that T is expressed in months. Okay, so let's try it out. So we have the future value, $681, and how many months are in 1.5 years? All right, well, you would do 1.5 times 12, if you didn't know, and that would give 18 months. Okay, so you're going to take that and split that amount over 18 months, and the monthly payment will be $37.83. Okay, so they'll pay that amount each month, and by the end of the 1.5 years, the entire loan and the interest will be paid off. Okay, we'll stop there. In the next video, we'll do a few examples with calculating either principal, rate, or time using the same formula, and we'll also talk about discounted loans.